C dash, that is your heat capacity, is equal to m into delta. Natural phenomena and the consequences of high specific heat capacity of water. So we start with the natural consequences. Natural phenomena and consequences of high specific heat capacity. Now we all know that the specific heat capacity for water is 4.2 joule per gram per Kelvin. Okay. Now this value happens to be the highest for any substance. Okay. If you see the table which is given on page number 265, okay, the heat capacity of some common specific heat capacity of some common substances, you will find that the water has got the highest specific heat capacity. Now because water has got the highest specific heat capacity, therefore there are some natural phenomena which take place due to this property of water. Okay, we deal with each of them one by one. The first is the climate near the seashore is moderate. Moderate. Alright, might have studied the coastal regions, the coastal places generally have the moderate temperature. Okay, they are not too hot or they are not, neither too cold. Alright, now why this is taking place? The basic phenomena behind this is the land and the sea breeze which is formed over there. Okay, formation. This is taking place because of the formation of land and sea breeze. So how the specific heat capacity, highest specific heat capacity of water is responsible for the formation of land and sea breeze. So during the daytime, if we consider one part as sea, so this is land and this is sea. So during daytime, if I say daytime, that is sun is shining, the rays of the sun are incident on both land as well as on the sea. Alright, so both are going to absorb heat energy. Now, what happens? The specific heat capacity of land as compared to sea is less. Sea means water. Okay, and if you observe the sand, basically if we are comparing the sea, the sandy area, okay, they are nearly having the specific heat capacity 5 times less than that of water. So what will happen? Due to the low specific heat capacity of land, this will get heated up quickly, and this will take time to get heated up. Now as this gets heated up slowly and here the heat is being gained quickly, so what will happen? The land will have low pressure. Low pressure on the land and high pressure on the sea. As the land is going to have a low pressure, so the wind, the air, the warmer air will be rising up. All right. As the warm air will rise up, so the cool breeze, as the warm air rises up, the cool breeze from the sea, this is cool compared, from the sea will be coming and taking up. Now this movement of the air from the sea towards the land is called as sea breeze. So you find that this cool breeze will try to moderate the temperature. This is during the daytime, that is the sea breeze is formed. Okay. Now during the night, the reverse will happen. Okay. During the night, reverse is going to happen. This is your sea, this is your land, so this is land, this is sea. So during the night, what happens? Since sea has absorbed more amount of heat, so it will lose the heat slowly, give out heat slowly. Whereas here, since it has less heat, so this will give out heat faster. As it gives out heat faster, so what will happen? This will cool, this will become cool, and this will be warm comparatively. If it is warm, it means that this is going to have low pressure, this is going to have high pressure. So warmer breeze will be rising up and cool breeze from the land will be coming over. This is called as land breeze. And this is all taking place because the water has got the highest specific heat capacity. Had the water not having the highest specific heat capacity, the reverse might have been taking place. Yeah. So this is how they are maintaining the moderate temperature. I hope this is clear to all of you. Any question? Yes, Ka. Please switch. I'm unmuting yourself. You can start your video and then ask the question.
सर आपने लिखा कि सी पे लो प्रेशर रहता है रात में, पर सर वो हाई प्रेशर रहता है सर. आप
don't get confused with the high tide and low tide. Don't get confused with the high tide and low tide.
Sir.
Okay. Comparatively, sea is warmer during the night. Okay. And land is cooler during the night. Now, based on the temperature, if you observe, if the temperature is high, okay, the pressure will be low. All right. So comparatively, the pressure on the sea will be less because the warmer air will be rising up. Why it becomes less? Because of warmer air. Warmer air, we all know that its density is less. So therefore, warmer area will be rising up, and a place will be vacated, which will be taken up by the cold breeze, which is coming from the land. Got it? So that is how the land and sea breeze is taking place. I hope it is clear to you.
Yes, sir.
Okay, beta. we move to the next. Yes, Kritin, what happened? Unmute yourself.
Sir, do we have to memorize this table of specific heat capacity of substances?
Which table?
The table given on page 265.
No. They are just given for certain values which you have to, you can see and understand. The table you don't have to mug up also. You have to just learn the values of water, okay? And most cases they will be giving you the values, okay? So you don't have to mug up. All right. So we move to the next. The hot water bottles are used for fermentation. Bottles used for fermentation. Now fermentation. Now fermentation, all of you must be knowing. It is a process of putting a hot water on a injured portion. Generally, when you get injured, okay, and there is a swelling on some part of your body, okay, so we put hot water bottles or hot water bags. Okay, this process is called as fermentation. हिंदी में हम सेकाई करना बोलते हैं इसको. Okay, now why we are using the water? Instead of water, if I take any other substance, they will have less specific heat capacity, so they will be absorbing less amount of heat energy. Since they will be having less amount of heat energy stored within them, so they will be able to give out that heat energy very quickly and will get cooled down very fast. On the other hand, water, since it has got highest specific heat capacity, therefore as compared to the same amount of other substance, the water will be absorbing more quantity of heat energy, so it will be able to retain this heat for a longer time, and hence it can be used for the fermentation. The next application is used as effective coolant. Water is used as effective coolant. Coolants have generally been used in the radiators of cars and buses, trucks. The purpose of coolant is to keep the engine cool. Now, engine during the working, it gets heated up. So we require that more and more amount of heat should be absorbed. So if you compare the other substance as compared to the water, since water has got highest specific heat capacity, so for the same amount of water, other substance, water will be able to absorb more amount of heat. So comparatively, water will be able to cool down the heat more quickly. Okay, so that is why we are using, and this is how we are using the highest specific heat capacity of water for all these purposes. Next is, in cold countries, water is used as heat reservoir. Water is used as heat reservoir, okay, for juice bottles and other things to avoid freezing. Now, in cold countries, the temperature goes below 0 degrees centigrade. All right. So if we are taking any other substance, so since they will be having a low specific heat capacity than water, so their reaching to their freezing point becomes more faster. On the other hand, water when we take, it is has highest specific heat capacity, so it will have to give out more amount of heat energy as compared to the same amount of any other substance, and therefore it is able to retain the heat for a longer time. Okay, so even at 4 degrees centigrade, and when the outside temperature is in minus, it will remain warm, and since it will remain warm, so what it will do, it will keep the juice and other things, avoid the juices and other things from getting freezed. Similarly, farmers fill their field with the water to protect the crop from frost. फ्रॉस्ट को हिंदी में बोलते हैं पाला मारना है. When there is intense cold, especially जब शीतलहर होती है, okay, the cold waves are moved. So what happens? The fields have been filled with the water to avoid the crops from getting damaged or injured, or you can say from dying off. The reason is that major portion of the animal or the plant is water. Okay, round about 70% is water only. Now these waters are present in a small amount through the capillaries and the veins present in the tissues present in the plant. Now since the quantity of water in the plant happens to be less, so it will have to give out less amount of heat energy, and it will reach to its freezing point very quickly. Once it freezes, it will damage the tissue and thereby the plant. Now what we do is, we fill the water, the field with water. So what we are doing, we are in the high the plant from getting reaching to its freezing point. Water, it prevents the water from reaching to its freezing point, and hence it prevents the plant from dying off. इस प्रोसेस को बोलते हैं कि पाला मार देना हिंदी में. All the plants and animals have high content of water in their bodies, and this is generally used for maintaining the temperature of the body. Even our body is able to maintain the temperature. Even during the summer, when it is intense hot, then also we are able to maintain our body temperature. When it is winter, when it is intense cold, then also we are able to maintain the temperature. This is all because around about 70% to 70% of our body is made up of water. And because water has got high specific heat capacity, so during the winter, it has to give out heat, so it will give out slowly. During summer, it has to gain heat, it will gain heat slowly, and thereby it is able to prevent the body temperature, maintain the body temperature. Okay. So this was about some natural phenomena. There are many more natural phenomena or consequences of high specific heat capacity. I hope you will be able to understand them. And then there are some examples of high and low specific heat capacity. Not a specific heat capacity. It's not a specific low heat capacity. That is thermal capacity. Low heat capacity. All right. The first in this case is the base of the cooking pan. Pan is made thick. The base of the cooking pan, that is pan, or you can have a kadai or anything, you will find its base will be thick. And generally, the purpose of making it thick is that once you increase the thickness, what you are doing, you are increasing the mass of the body. Once you increase the mass of the body, the heat capacity of the body is going to increase. As the heat capacity of the body increases, so now the body will get heated up slowly, and therefore it will impart the heat to the cooking substance, your food item which is to be cooked slowly, and in that case it will avoid burning of the food item. Okay, it for a long time also. All right, so what it does, when we are increasing the making the base thing, and thereby it is used to impart the heat slowly to the items which is to be cooked, and the item gets cooked very efficiently. Otherwise, if we are making the base thin, quickly it will get heated up. Keep in mind its specific heat capacity will be less, mass is less, so it will get heated up very quickly. As soon as it gets heated up, it will impart the heat to the cooking item. So maybe from outside the cooking item, suppose if you are cooking a potato, the outside it will be cooked, inside it will not be cooked. Okay, because it requires slow cooking, and because the base is thin, so it will impart the heat very quickly, उसमें खाना जल जाएगा. So इसलिए the base of the cooking vessels are generally made thick. The base of electric press is made thick and heavy. Base of electric press is made thick and heavy. Here also the same concept. While we are doing the ironing, okay, pressing our cloth with electric press, what happens, it gets heated up, and then the power, there is an auto cut, so the power will not be there. Now if we make it thin, so it will get heated up very quickly, as well as when there is a power cut, it will lose out the heat also very quickly. Another thing, since it gets heated up very quickly, so it might burn or damage your cloth. But once we are making it thick, so it will take time to get heated up. Okay, but once it gets heated up, it will also take time to get cooled down. This is because of the increase in the heat capacity due to increase in the mass by making it thick and heavy. All right, so this is how we are using the electric press, or the concept of heat capacity is being used by increasing the thickness and heaviness of the electric press. And the last question is, the vessel used for measurement of the heat is made made of thin sheet of copper, calorimeter. The vessel which we are making, I had already told you, that is also going to absorb the heat. Now here if we make it thick, it will absorb more heat. So it should be made thin so that it takes up the heat very quickly. Okay, and it takes very little amount of heat. So mass is less, so the amount of heat absorbed will be less, and therefore it is made very thin. Okay, so I hope this is clear to all of you. Any question? Yes, Kritin? Unmute yourself, ask your question.
Sir, can you give another example where thin sheet of a substance is used, low heat capacity is in use?
Generally, thermometer, if you are taking, the glasses which we are using, especially laboratory thermometer, they are thin glasses. All right? The mercury, the bore of the thermometer, if you see, that is also very thin, so that less amount of mercury has been used, and it absorbs less amount of heat but expands more. All right, and similarly, wherever we are using these type of measuring instrument where the heat is to be absorbed, we will be using the thin material. Okay, if it is not required to be affecting the phenomena.
Okay, sir. Thank you.
Okay. Anyone else? So now we finish off with this first portion of the calorimeter. We will the rest of the numericals you will be doing. Before that, just mark from exercise 11A the questions you will be doing in your copy. Question number 3, define the term calorie. Question number 4, define 1 calorie of heat. Question number 10, how is heat capacity of body related? Question number 11, state 3 differences between heat capacity and specific heat capacity. Question number 14, what do you mean by the following statement? There are 2 parts in this. Question number 23, why do the farmer fill their field with water on the cold winter night? Question number 24, discuss the role of high specific heat capacity of water with reference to the climate in coastal areas. 25, water is used in the hot water bottle for fermentation. Give reason. 29, what is calorimeter, and the remaining questions of that. And question number 30. Okay. So we will start with the numericals. Now keep in mind the first question, by imparting the heat to a body, its temperature is by 15 degrees centigrade. What is the corresponding rise in temperature on Kelvin? I'll just quickly tell you. You all have studied also. The temperature in degrees centigrade and the temperature in Kelvin, there is a difference of 273. But the change in temperature for in Kelvin is same as the change in temperature in degrees centigrade. This is very important. This I have also explained while explaining the temperature, the units of temperature. Therefore, if there is a 15-degree rise in temperature, this is equivalent to 15 Kelvin only. Okay, so change will always be same. So wherever we are using, and in this portion, whenever we are using the temperature, we are basically using the change in temperature, and therefore in degree centigrade, the unit in degree centigrade and in Kelvin will remain same. So the change will remain same. We start with the second question. Second question says, calculate the heat capacity of the copper vessel of mass 150 gram. So mass of the copper vessel is 150 gram. Okay, mass is 150 gram. Specific heat capacity C is equal to 410 joule per kg per Kelvin. Now if you observe, the specific heat capacity is in kilogram SI. So we'll change this also into SI, and this will come out divided by 1000, and it will come out to be as 0.15 kg. Now we have to find out the heat capacity. Alright, so the relation between the heat capacity and specific heat capacity we are already aware. C dash is equal to M into small c. So this will be equal to 0.515 into 410. Okay, this comes out to be 61.50 joule per Kelvin. Okay, keep in mind these two process is important. I have already told you quite many times. That is formula, wherever applicable, please write down the formula, and substitution of the value should be shown in the formula. Then whatever way you want to calculate, you calculate it. This was the first part. Okay, this was your first part. The second part is ask you, just clear this. Second part, it says how much heat energy will be required to increase the temperature of the vessel in part A from 25 degree to, so T1 is 25 degree centigrade, T2 is 35 degree centigrade, so delta T will be equal to 35 minus 25 is equal to 10 degree centigrade. So we have to calculate now the relation between. Now we also know that C dash, heat capacity, is equal to Q upon delta T. Alright, so what we have to find out? We have to find out Q, the amount of heat energy. So Q will be equal to C dash into delta T. C dash, we have already calculated it as 61.5 into delta T is 10, so it comes out to be 615.02. The unit of energy will be joule. I hope clear, it is clear to all of you. Any doubt? You can raise your hand. Okay. So we move to the next question. That is question number 3. Question number 3 says, a piece of iron of mass 2 kg. A piece of iron of mass 2 kg. So mass is equal to 2.0 kg. Has heat capacity, that is C dash 966 joule per Kelvin. Okay. Find the heat energy needed to warm it by 15 degree. So first part, warm it by 15 degree means the change in temperature. Delta T is equal to 15 degree centigrade. Now I told you that change in temperature in CG, in your centigrade and Kelvin are same. This I can also write it as 15K. Keep in mind, Kelvin is not in degree. So keep in mind all these things. So now what we have to find out? Heat energy needed, that is Q. So Q will be equal to C dash into delta T we have just now written. C dash is 966, delta T is 15. On calculation, you will get the value as 14490. Now, second part, we have to find out the specific heat capacity. We have to find out C. You can use any of the formulas. Either you can use Q is equal to MC delta T, or you can use Q is equal to C dash into delta T. So C will be equal to Q upon M delta T. Q we have already calculated. I'm putting it because so that the simplification will become easy. I put 14,490 also upon 2 into delta T is 15. So when you solve it, you will get it as 483 joule per kg per Kelvin. Okay, mass is given in kg, so you will get the values. I hope this is clear to all of you. Any doubt? You can raise your hand. Alright, so we move to the next question. Question number 5. Says that 1300 joules of heat energy is supplied. So Q is equal to 1300. Always write down the data which are given, that will make it easier for you to calculate. Rise the temperature of 0.5 kg of lead, that is mass is equal to 0.5 kg. From 20 degree centigrade, T1 is equal to 20 degree centigrade and T2 is equal to 40 degree centigrade. Calculate the specific heat capacity. So delta T we will calculate here only. This will be 40 minus 20 equal to 20 degree centigrade equal to 20 K. We have to find out C, specific heat capacity. So Q is equal to MC delta T. So C will be equal to Q upon M delta T. Alright. So if you put the values, you will get the answer. So Q is given as 1300, M is given as 0.5 and delta T is 20. So once you calculate it, you will get the value. Okay? I'm not writing down the calculation. Next question. Question number 7. An electric heater of power 600 watt. So power is given as 600 watts. This rises the temperature of 4 kg of liquid. So mass of liquid is 4 kg, 4.0 kg. From 10 degree to 15 degree. T1 10 degree centigrade, T2 15 degree centigrade, so delta T is equal to 15 minus 10, 5 degree centigrade equal to 5 Kelvin. Taken in 100 seconds. Time 100 seconds. Calculate the heat capacity of 4 kg of liquid. Alright. So here we have to calculate the heat capacity. Now here one thing you have to keep in mind. That is the heat energy which has been given. In this case, this is nothing but power into time. So Q will be equal to T into T. You all know that heat is a form of energy, and the relation between the energy and energy is equivalent to work done. Alright, capacity to do work. Now we all know that power is equal to W by T. Now W can be replaced by energy also. So heat energy will be equal to P into T. W will be equal to P into T, or we can write down heat energy is equal to P into T. So this is the concept which we are using, which means that now when we are writing down Q equal to mc delta T, we can also write down it as P into T is equal to mc delta T. So from here C we can calculate, that is P into T upon m into delta T. So power is given as 600, time is given as 100 seconds, mass is given as 4 kg, and delta T is 5 Kelvin. So once you solve this, you will get the value as first part you have to find out. This is your second part actually. Okay, in first part, this is your second part. This will give you 3000. First part you can calculate from here also. I'm just rubbing this portion. In first part you have to find out the heat capacity, that is C dash. So C dash is equal to Q upon delta T, that is Q here will be P into T upon delta T. So this will be equal to 600 into 100 upon delta T will be 5. So this will give you the heat capacity. This is first part, and this comes out to be your second part. So I hope up till here it is clear to all of you. Any doubt? The remaining questions you will be doing it by yourself. In case of any doubt, you can send me your query. Anybody having any question? It's already 55. Okay, I'll solve one more question because 55 and nobody is having any problem. Nobody is raising their hand. So I'll just try to solve one more question. Now here, the question is basically based on the principle of calorimetry. Question number 9. Mass of 50 gram of certain metal. So let the mass of metal be 50 gram at 150 degrees centigrade. Temperature of metal is 150 because here we are using two substances. So I am giving the subscript to make it clear what we are using. Is immersed with 100 gram of water, that is mass of water 100 gram at temperature of water 11 degrees centigrade. The final temperature final, I'll mark it as EF, which is equal to 20 degrees centigrade. Calculate the specific heat capacity of metal. C of metal we have to find out. C of water is given as 4.2 joules per gram per Kelvin. Now if you observe, the unit in which the specific heat capacity of water is given, that is in gram. So we need not to change the mass into gram. Okay. So whenever we are required to change the units, you keep in mind what units we are using in a specific heat capacity. If it is in gram, let it be in gram. If it is in kilogram, then you require to change it into kilogram. Now here, according to the principle of calorimetry, according to principle of calorimetry. Heat lost by, now heat lost will be equal to heat gained. Now who will be losing the heat? The metal is at a higher temperature, so the metal will be losing the heat. So the heat lost by the metal. Now heat loss will be equal to mc delta T, that is mass of metal, C of metal, and here that this will be your temperature of metal minus the final temperature. This will be equal to, heat gained will be by water, which means mass of water, C of water. Now water is at a lower temperature than the final temperature, so Tf minus Tw. This is how we can make the formulas. Okay. Now put the values. Mass of water, mass of metal is 50. C of metal we have to calculate. Temperature of metal is 150 minus temperature, final temperature is 20. This is equal to mass of water 100, C of water 4.2, difference 20 minus 11. Okay, I'm now rubbing the upper portions. So now when we try to calculate, so this will be your into cm into 130. This is equal to 100 into 4.2 into 9, or cm will be equal to 100 into 4.2 into 9 divided by 50 into 130. And once you calculate this, you will be getting it as 0.58 joules per gram per Kelvin. So I hope this is clear to all of you. Okay. Now I am going to stop this because time is up. Yes, Kajal, quickly unmute yourself, tell your problem, because it's already 11. Kajal, unmute yourself. Kajal Yadav. Okay, so we'll continue. So put your problems in the